Hello everyone. Our topic for this workshop is trust. Here we will have a brief introduction of this type of structures and also its applications. And then most important, we'll focus on two methods of doing structural analysis to each member of the trust. So first of all, we need to know what is a truss. Since the slide shows, a truss is a structure composed of slender members jointed together at their endpoints. I'm sure everyone has seen trusses in their daily lives, in either on bridges or roofs, and a truss can have different shapes depends on their usage. But normally, as we're talking, they're jointed at this end point, and then there's normally a plate which is called gusset plate. All the members are bolted to this plate, and then they make a connection, which is a zero moment connection. And then also pay attention in this section when we're calculate or doing the structural analysis of each members, we only consider the axial forces. So here we're talking about the application of the trusses. The trusses are very widely used for roof systems and also bridges. So I think it's very important to point it out that the trusses are normally used for resist the loads on a very large span, such as museums and exhibition halls or concert halls or warehouses. And then when we have a very large space, and then we don't want any columns in the middle. The trusses are compares with normal beams when they're using for resist the large span load. The beam are very easily bended, and they're a very large load. But then the trusses, we can always increase the depth to resist the load, and then the trusses would have smaller deformation compared with the beams. So now we are starting our main topic of the workshop, the two methods of doing truss analysis. Here, the first one we're talking about will be the method of joints, and then the second one would be the method of sections. And then also, the trusses that we're doing analysis for now are all statically determined. That means when we establish a equilibrium, we can solve all the unknowns. So first of all, we're going to talk about the method of joints. How this method works out is because that if a whole truss system is in equilibrium, then every joint, when we take out doing analysis to each joint, then every joint of the truss is in equilibrium as well. And then from this, we can establish the equations which contain the unknown forces. And then by solving these equations, we can find all the forces in each member. So the procedure, normally we can start off with one of the end joints. That's because we want the unknown forces to be less than 2 in order to start off our analysis. So after we pick a joint to start off with, we isolate this joint from the whole truss system and then establish the x and y axis for it. And then the next step would be establish the equilibriums. So the equilibriums comes from the sum of forces on the x-axis equals to 0, and then the sum of the forces on the y-axis equals to 0. So from these two equations, we'll have 2 or less than 2 unknowns, and then we'll solve the unknown, find the value, and then this value will be the given value for the next joints that we're going to analyze. So we'll have an example to show you how exactly the procedure of the method works out. But then before that, I would like to introduce some trick or tips to do structural analysis for the trusses. First of all, normally when we start to analyze the members, the forces in each members of the truss, we always start off to find the reactions. This is because that we need to find out more given values in order to start off our analysis. So, how do we do this? We take the whole structure and then we do the sum of the forces equals to 0 and then the sum of the moments equals to 0, just like how do we do like a normal analysis to beams to find out the reaction forces. And then there are two special cases that I would like to point out. First is that when we have symmetric truss systems. So here symmetric actually has two aspects of meanings. First is that the shape of the truss has to be symmetric. Well, I'm sure everybody can visualize how is a symmetric truss look like. And then second is that the forces applied on the truss has to be symmetric as well, and then they have to have the same middle axis as the shape of the truss. So when both of these two symmetrical things are satisfied, then when we do structural analysis to the trusses, we only need to do half of the truss and then just mirror the forces to the other half. So this way it will simplify our procedure a lot. And then also we have to pay attention to the zero force members. So I'm sure that people will have the doubt that why do we still need to put the members in the truss if it doesn't resist any load? These members normally works for just maintain the shape of the truss and then also resist some deformations. Excuse me. So identify these two types of special cases will largely help us to just make our procedure easier. Okay, we see that there are only two members connected to joint F, and then also we have a reaction force that we already know. So we start off our analysis by finding the reaction forces on the two joints, the two supports on the lower two quarters. So here we take the whole structure into consideration, and then we write down the equilibrium equations. So the first one would be the sum of the force on the x-axis equals to 0. And luckily we don't have any the forces on the x-axis. So this is easy. And then we have the forces on the y direction equals to 0. So we have the reaction at F plus the reaction at J, and then minus all the loads equals to 0. And then the third equation would be the sum of the moment about any of the joints on the trusses equals to 0. So here I took the moment about F. So we have the reaction at joint J times the level arm 40 inches minus all the loads times their level arms equals to 0. And then by solving these two equations, we find out that the both of the forces at F and then at J are all 50 kips. So then we establish the x and y axis, and then we have the sum of the force on the x-axis, which is only the forces on member FG equals to 0, and then we find out that FG is a zero force member. And then also we have the sum of the forces on the y-axis equals to 0, and then we have 50k minus the forces on member AF equals to 0, and then we find out that the forces on AF is 50k, which is in compression. And then after we find out the forces on the force on member AF, and then we can move to the next joint, which is the joint A. And then now the force on member AF becomes an given force, and then we still only have two unknowns, which is the force on member AB and then the force on member AG. So the same procedure, we establish the x and y axis, and then we have two equations, which is the sum of the forces on the x axis equals to the force on AG times the angle, which we have to project um, the force AG onto the x-axis. So that's why we use the force AG times sine 45 degrees minus the force on AB equals to 0. And then we also have the forces on the y-axis, which is 50k minus the forces on AG, the projection of the force on AG, minus 10k. And then we find out that the force on AG equals to 56.6k, which is in tension. And then also the force on AB is 40k in compression. And then we use the same procedure to analysis to joints B, C, G, and H. And then also, as we talked about before, this truss is symmetric, so we only need to find the forces on the left side of the members. And then each member on the right side will be the same as the corresponding symmetric member on the left side. So after we do all the analysis to each joint, and then this diagram shows the final result of the forces on each member. So if a truss is loaded like this, it's supported on the bottom and not loaded on the top. So we can see that the top chords are all in compression, and then the lower chords are all in tension. And then also the braces members are in tension as well to hold the trusses in shape. So we progress into the next method, the method of sections. The principle of this method is that when a whole truss system is in equilibrium, we take out any section of the truss. This section has to be in equilibrium as well. So the procedure, we start off finding the reaction forces just as we did for the method of joints. So the second step, which is very important to make sure that you're doing the rest of the analysis okay, is that we have to make a cut through all the members that we're asking to find out the reaction forces. So don't don't think that the cut has to be in a straight line, and then don't hesitate to cut it if the cut is in a very odd shape, because any section of the truss has to be in equilibrium if the whole truss is in equilibrium. So then this way we can expose all the reactions in the members and then just do a whole equilibrium analysis to the section that are being isolated. So the next step, it would be to establish the equilibriums. So as we talked about before, this way would be the sum of the forces on the x-axis equals to 0, the sum of the forces on the y-axis equals to 0, and then the sum of the moment about any point on the section equals to 0. And then at very last, just a reminder, assume a direction of the force when you start off your analysis, because before we find out everything, we don't know that if the member is in compression or tension. So just assume a direction, and then finally if it turns out to be a negative value, that means you assume the wrong direction. So just reverse it, and then that will be the final result. So again, before we start off our example, just a quick tip on when do we use the method of sections and when do we use the method of joints. So the method of sections are always very efficient when we some particular members in the middle of the structure are need to be calculated. So this way we can just make a cut through the members instead of start with the joint at the very far ends and then eventually progress to the middle. So, but many times the method of joints and method of sections are used together to do the truss analysis. Okay, so our second example for the method of sections. The same truss as the previous example, but now we only need to find the forces in member BC, BH, and GH, which are the three members here in the middle. And then the first step is the same as we did for the previous example, that we have to find the reaction forces at the two supports. So the steps are the same. We have the forces on x equals 0, and the forces on y equals to 0, and then the sum of the moment equals to 0. And then we find out the same number for the reaction at F and J, which are 50 kips. The reason that I took the moment at B is that there are three forces all go through B, so this way I can eliminate more forces to just make the equation to be simple. So now we have the force on GH times its level arm 10 inches with the sum of the moment of 10 kips times level arm of 10 inches, and then the sum of the force at the support of 50k times level arm of 10 inches equals to 0. And then from the three equations, I find out that the force on GH equals to 40k in tension, the force on BG equals to 28.3k in tension, and also the force on BC equals to negative 60. This means that I assumed the wrong direction of this force, so I just reversed it, and then I find out that this force on the member is a compressive force. So now we can compare the result with the previous example, and then we saw that the results are the same. So here's the end of this workshop. I hope that you will have a good understanding on trusses now. Thank you.